All right. Okay. All right. That's actually normal now. All right. Uh, I'll increase my volume a little bit. But so what I was saying was, we're gonna get right into it. Today, we're probably gonna do some more chemistry, probably some cars. I expect today to go pretty quickly. We're gonna do the periodic table, and then we have like 100 reviews today, so it's gonna take a lot longer than yesterday. Um, which is I guess to be expected. Um, so we have 75. We're gonna do 75 cards, obviously again. I'm thinking I kind of want to do chapter 2 and 3, or depending on how long it takes me to do these 28. These 28 should be like trends, like and the bonding and chemical interactions. I'm thinking that those will probably be. I'm thinking that those will probably be um, like pretty simple too. I don't think that they should be too difficult. Uh, I'm trying to stray. I'm gonna try to stray away from just doing all of the quote unquote like easy subjects for me first. I think bio and biochemistry is gonna be like one of the hardest, alongside I guess Oregon physics. So I don't really know. Bio and biochemistry, I just feel like are gonna be more in depth, and it's gonna be harder for me to just like guess an answer or figure it out on the spot. But I'm not too sure. Uh, but we can what we can do is I guess we can come into here. I just don't wanna I don't wanna risk I just I don't wanna risk I'm just gonna do zero. I'm gonna put 0 new cards per day for now because I just wanna run through all the reviews first. 3% done, guys. 3% done. That's like terrible. Um but 1% better each day. Uh, is that electrical activation? Bro, no way. We're already starting with this. Is electric transmission. States that similarity. Sclera. When it's bright outside, our pupils um, constrict, desensitized. A beta pleated sheet is a structure formed by peptide chains lying right next to one another, forming rows. Oh, nice. What are lysine structure? All right, lysine is like this, and we do like you make both of those into K's, and you have uh this right here is going to be an NH3. Obviously one letter is K. It's lice. Yep, nice. I didn't say it was basic, but obviously it's an amino group. Conscious sensory experience of neural processing perception. Conjunctiva is the thin layer of cells lining the inside of the eyelids. It's initially bent at the cornea. This might result in some false alarms, but you'll get all hits. Glutamine is GLN, and it's Q. Uh, Glutamine is boom, 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 and that's a amide. Secretes aqueous humor, the ciliary body. States that the mind perceives objects as being symmetrical and forming around the center point. Symmetry. When a subject responded affirmative when a signal is present, a hit. What is it? What will the titration? It's a combination of 2 or 3 monoprotic titration curves. What is quaternary structure? It's a combination of 2 or more polypeptides to form the overall um, quaternary peptide. Um, Is the inside back area filled with photoreceptors? Also, I don't know if you guys watched the last episode, but there was some really weird audio. I'm sure is what it sounded like. There was some really weird audio going on in the middle. Pretty much, I used some like lo-fi that was supposed to be no copyright, and the I literally got like five copyright claims on it. So yeah, that's the reason why there's like audio that's like really weird. I think it should only happen in the beginning of the video. I don't know why it only occurred there, but yeah, that's why it's like really weird in the beginning. All right, I want to read. Let me click OK on this so that it's like actually tracking the time. Is the inside back area filled with photoreceptors, the retina symbol for the strategy used. Um, C is the area behind the iris to the back of the lens on the posterior chamber. Try to explain how we perceive things the way we do. Uh, rods. That was kind of hard. It's a monocular cue that can give a sense of depth through motion. It states that things farther away move slower. It's motion parallax. What bends light so it goes to the back of the eyeball of the lens? Thin layer of conjunctiva. Off bow, it says that you fill the orbitals from lowest energy level to highest energy level. It's to always say no unless you're 100% sure that the signal is present. This might result in uh, some, what is the word? Some misses, but you'll get all correct rejections. Is a special, this is the macula. Monocular cue that uses light and shadows, shading and contour. Is to always say yes, the liberal strategy. Always say yes. The lens can change shape with the assistance of the suspensory ligaments. Vitreous humor um, maintains pressure in the inside of the eyeball, and it provides nutrients to the inside of the eyeball. Is when it gives a negative answer at the correct rejection. Allow us to perceptually organize. Gives the iris fires at the beginning, then it stops, and then it begins firing at the end again. Is filled with vitreous humor, which is a jelly-like substance on the vitreous chamber. Bottom of processing begins with the um, it begins with the stimulus. Rods detect blank. Rods detect uh, light and low levels of detail. Oh, sorry. Oh my God, I'm doing it again. It's probably because they tried copyrighting my video. Let me put the lo-fi on. Like actual, like it's not gonna get copyrighted. Okay, okay, that should be good. Um, let's see. All right. Um, rods detect light and low. Depth for motion constancy. Things farther away move slower and closer move faster. Under some circumstances, the law of past experiences. That's the reason why you don't combine an L and an I when they're together to think that they're like a U. Like law of past experiences, from my understanding, is just it takes priority. What is an oligopeptide? An oligopeptide is a chain of amino acids that's 20 amino acids or less. Uh, I think that's, I'm gonna say that's accurate. What is a tertiary structure and what is its characteristic bond? That is the 3D structure of a peptide, and its characteristic bond is hydrogen bonds that hydrogen bonds between side chains, salt bridges between negative and positively charged side chains, and disulfide bridges. I mean, bonds, same thing. I think no, it definitely is bonds, but I still give myself that right. Disulfide bonds. What pulls on suspensory ligaments to change the shape of the cell? Ciliary muscle. What requires a physical stimulus to be converted? Sensation. States that lines are seen as following the smoothest path. Continuity. Phobia. Anterior chamber is filled with aqueous humor. You have heat, which destabilizes hydrogen bonds, and I always forget the second one. It destabilizes hydrogen bonds. This is like really loud now. Like this got a lot louder. Um, okay. So it destabilizes. You guys even hear that? Can you even hear the music? There you go. Uh, what are common methods? So, yeah, so heat destabilizes hydrogen bonds and salt bridges. I don't know why I always forget about salt bridges. Um, Hydrogen bonds and salt bridges. Then you have solutes like DTT and beta mercaptoethanol that are gonna disrupt disulfide bonds, and then detergents are going to disrupt non-covalent bonds. Somatosensation, thermoception, top-down processing uses deductive reasoning, or damn background knowledge, which is driven by theory. The conservative strategy. Sorry. With basic side chains have high PIs. Cornea is a cornea is a transparent, thick, fibrous sheet of tissue, uh, primarily bend light into the eyeball. A different order of the words, but yeah. Bottom up processing uses inductive reasoning, and it's always correct. Cornea. Bottom up processing is driven by um, hmm. Bottom up processing is driven uh, by data. Transduction. Then is a monocular cue where an object is perceived as being further away when it's higher in the visual field. Relative height. The objects grouped together are seen as a whole and mind closure. The symbol for strength, D prime. St- Why does that say 1 day? 1 day. Oh, that was yesterday. Sorry. States that our brains organize and reduce pragnans. Somatosensation of pressure is called uh, mechanoception. Visual cues that are a result of humans having two eyes, they're called binocular cues. Leucine structure is um, leucine structure goes something like boom, boom. I had to think about that. So I guess it's working, but it's blue. LEU and L. It's obviously non-polar. Weber's law states that the just noticeable difference divided by the initial intensity is constant. It's a black of blood vessels. Blood vessels. Sorry. It's space filled with aqueous humor in the front of the eye anterior chamber. It forms to maintain pressure and give shape to the eyeball, to the front of the eyeball, and to provide nutrients to the cornea and iris. It's a muscle attachment point, and it provides an extra layer of protection to the eye. Visual cues, uh, bottom up. Um, Perception, choroid, monocular cue that states our perception of an object doesn't change even if constancy. The absolute threshold of sensation is the minimum intensity needed in order to perceive the perceive the stimulus 50% of the time. The pupil's main function is to constrict and dilate to modulate the amount of light entering the eye. Um, the autolytic help detect linear acceleration and head positioning. The macula is a special part of the retina rich in cones. If pH is lower than pKa, then that group is going to be the group is going to be protonated. The iris's main function is to uh, contract and dilate in order to control the size of the pupil. Yes, whatever. Tryptophan structure, it's also a W. It's WTRP. Um, boom, 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 boom. This, this, and. And then we have obviously, like, just so y'all know, just so that y'all know that I still got it. Uh, Obviously, I do not still have clean handwriting, but something is something, right, guys? Uh, Look, and y'all gonna see that it's gonna pop up right there, this exact same structure. Watch. Just so that y'all don't say that I'm half-assing them. Let's just do the H's so that y'all see. See, guys, I told you, I still got it. This is like an this is like a letter in like Greek or something, but detect color and discern cones. It's a combination of ciliary body. States that the situation in which stimuli are presented and the processes of perceptual organization contribute to how people perceive those stimuli. Um, Stimuli are presented and the processes of perceptual organization. Oh, this is contextual effects. Top-down processing uses in no deductive reasoning. Sorry, neurotransformation processing. Cones detect color and high levels of detail. Objects that are close together or grouped together. Um, Proximity. Radix Gestalt principles states that humans perceive visual elements that move in the same speed and or direction as parts of a stimulus. Law of common fate is when the subject perceived the signal when there was none present. False alarm. Sensory adaptation. Special part of the macula. The posterior chamber is filled with aqueous humor. Sensation requires a blank to be converted into a neural impulse. Sensation requires a Physical stimulus. Proprioception. What is cystine? It's a it's what you use the name used to refer to a disulfide bond that forms in a protein. Nice. Okay. So now we about to go. We are about to go crazy. Okay. Let's go crazy with this basic chemistry stuff, or quote unquote basic. It's supposed to be basic for sure. How basic I'm gonna make it look, I can't tell you that. I'm gonna be honest with you. Um. All right. Let's not bio, not biochemistry. We're not going back to biochemistry anytime soon, bro. Or well, sometime soon, but just not today. We actually got permission from Yusuf Hassan to watch the videos on stream. So probably sometime soon I'm probably gonna start doing that too. I'll probably like allocate like some like longer time slot so that I can actually do this. Um Maybe sometimes I watch it on stream. Sometimes I might watch it outside. I haven't watched any yet though, so you guys haven't been. I haven't been like not showing that part. I think I mentioned it before, but I mentioned before that I was gonna try watching it before stream, but I never actually did that. So you guys haven't missed anything. Um. Uh. Why did I close out the chemistry section? I need that. All right, we're doing periodic table. This I feel like is pretty intuitive. Like this is gonna be like periodic table trends. This should be pretty intuitive. Like 28 cards on that. Like man, that's like Swiss cheese. Um, I think I shouldn't even say that. Let me not say that. What is the ionization energy? What is the ionization energy periodic trend? Um, well, as you go from left to right, ionization energy. Okay, so first we have to know what ionization energy is. So that's going to be the energy it takes to, I think, remove an electron. So as you get closer to the right side, you're going to require more energy to rip it away, I think, or less. Nah, probably more energy because you get smaller, I think, from yeah, I think you get smaller from left to right. So ionization energy, because you're getting closer to the nucleus, it's going to be stronger, and that's going to cause the ionization energy to increase from left to right, and it's going to decrease downward because you're obviously getting further away. So it's going to it's going to it's going to increase going toward wait, hold up. It's gonna increase going like a diagonal, like y equals x, like that type of like diagonal, like exactly that diagonal. Yeah, literally like going from here to here, like like combination of like vectors, like it's increasing in this direction. Yeah, I mean I kind of figured that out. It was definitely hard, so I guess I'll give myself hard. What is a period in regards to the periodic table? That's a row. What is the electron affinity? Okay. This with electron affinity, I don't actually remember what electron affinity is, unfortunately. So it okay. I don't remember what electron affinity is. So I need to figure that out before we continue with this. And I'll probably write it on the card. Um Meaning. Okay. All right. All right. That should be good. So it measures how strongly an atom wants to attract an extra electron. So it's like the exact opposite of the last one of ionization energy. But it's kind of at the same time it maintains the same trend, although technically I guess it's the opposite because electron affinity you're gonna have like it's how badly it wants an extra electron versus the last one was how bad it's like it wants that extra electron so bad that it doesn't want to let it go. So they maintain the same trend as a result of that. So electron affinity has the same it's gonna have the same trend as ionization energy. Okay. Where are metals found? Like group I want to say like 14 to maybe 16 ish. Oh damn. Oh damn. That was that was like terrible. I was thinking the metalloids. That's why. Uh and even then I think I was still wrong. Um I feel like this is a bad card. I feel like this is a bad card. It's like I feel like you just kind of need to know that. Like you need to know which ones you but you just I feel like they're gonna give you a periodic table on the MCAT. MCAT periodic table. I'm gonna look it up. And I'll just say to the stream what it says. Yeah, so okay, so it gives you a very basic periodic table. It doesn't tell you which ones are like which ones are the metals and stuff. But it's like you don't even really like like come on now, like are you gonna look at manganese and think that it's a gas? I don't know. I just like you you might just have to associate one with another. Like looking at like nickel, like you might have to just know since it's in the same like vicinity, like it's gonna be the same thing. Like it's a transition metal. Um, you're just gonna need to acknowledge that. Like silver, like anything in that same transition level area is gonna be the same. Or like osmium, lead, like yeah. Okay. Like you could look at some of these and think that they're gas, but maybe. I don't know. I wanna suspend the card, but at the same time I don't. What is a group in regards? That's a column. I'm gonna give myself easy on that. I know that. Where are metalloids on the periodic table? That's like those only exist on like past group 13 between the metals and non-metals. All right. Where are the alkali metals? That's group 1 and 2. Oh damn. Always confuse them because one is like alkaline earth. I always confuse alkali metals and alkaline earth or whatever they're called. I guess we'll see soon what they're actually called. There it is. It is alkaline earth. I always confuse them. Where are the noble gases? Um, maybe it's gonna be that's is that group 17? Damn, damn. That was really dumb. What are the general characteristics of metals? Um, uh, at least one of them is gonna be ductile. Um, ductile, shiny, lustrous solids with high melting points, malleable and ductile, Good conductors of heat and electricity. Okay. This card is gonna take me a while since it's a list. Where are metals found? Like the left side in the middle. Where is the ionization energy? It's going up toward helium. Diagonal toward helium. Y equals X. Increasing Y equals X is what I should say. I'm gonna give myself hard because I obviously could figure that out. Where are metalloids on the periodic table? They're gonna be between the metals and the non-metals, I guess. Where are the alkali metals? Group one. Where are the alkaline earth metals? Group two. Where are the noble gases? Group 18. What direction does electronegativity trend go? Um, I kind of want to say like technically like it increases going toward what is it? Fluorine. It increases toward fluorine. Like probably Y equals X too. Okay. Um, what are the general characteristics of metals? Um, okay, so it's gonna be um, it's gonna be lustrous solids with high melting points. Um, Malleable and ductile. That's not me winking, by the way. I have something in my eye. General characteristics of metals, malleable and ductile. Uh, what's the last one? I don't remember. Good conductors of heat and electricity. Okay. Electron affinity, it's Y equals X. Increasing toward Y equals X. Damn. In what direction does the electronegativity trend go? It's still Y equals X. Where are the halogens? The halogens are in group 17. As you move from left to right on the periodic table, in what way do elements change? That's does it want literally every trend? Like, from left to right, they decrease in radius. From left to right, they decrease in radius. They increase in electronegativity, increase in electron affinity, and increase in ionization energy. Oh, okay. I didn't. I really hope they have a separate one for effective nuclear charge. Let me check. Bro, they make these cards in such a strange order. Like, I don't think you understand. This is such a strange order. Elements have, um, as you move from left to right on the periodic table, in what way do elements change? More protons, electrons, and neutrons. Okay. And then a more effective nuclear charge. They better give me the formula for effective nuclear charge at least. I think probably effective nuclear charge is probably increasing across Y equals X2. Let's look that up because I had it. They have it in the miles down, but I guess Captain Hook doesn't have this one. Zeph periodic trend. Uh, Oh, it actually goes down. It is not, in fact, y equals x. More like y. What would that be? Like y equals negative x. Like basically like the opposite. Yep. All right. Cool. Uh. uh it's not really like the Zeph is the only thing. Zeph only increases from left to right. Really. Why is this? Hold up. Because one of these sites is just plain lying. A couple of these sites. A couple of these. I don't know what the trend is. Um. I'm just gonna. I'm gonna go with what they tell me. To be honest, I guess we can go with what they tell me. I thought that. I think I might have edited the card on Miles Down. So that's the biggest problem here. That I think it was the same trend on Miles Down, but I also was the one that might have put the picture that showed it being that way. What are the general characteristics of metals? Lustrous, solid, um, with high lustered solids with high melting points. Um, then it's gonna be hold up. Uh, it's gonna be lustrous solids with high melting points. It's gonna be um, they're gonna be malleable and ductile, and they're gonna be good conductors of heat and electricity. 1 second. So, um, let's see. All right, I think I got that right. Uh, then what is a period? It's a row. As we move from left to right on the periodic table, in what way do the elements change? They get more electrons, protons, neutrons, and Zeph. Where are metals found? The left side in the middle. What is the ionization energy periodic trend? It's Y equals X. Where are metalloids on the periodic table between the metals and the nonmetals? Where group two, group one. Where are the noble gases? Group 18. What is the electron affinity trend? It's going to be Y equals X, increasing Y equals X. What is effective nuclear charge? I don't remember, to be honest. Attraction valence electrons have to the nucleus, considering shielding. So it's protons minus shielding electrons. So Zeph is fundamentally equal to the number of valence electrons. That doesn't sound right to me. Okay, so it's the number of valence electrons, unless like I mean, I guess even in the case of ions, it's technically always going to be the number of valence electrons. Like for sodium, if it loses its outermost electron, then it's going to be its new valence electrons would not be in the third shell. Um, or I guess hold up, let me pull up a periodic table. P table, the goat. Um, yeah. Anyways, I was right. So three, it wouldn't be in the third energy level anymore. It would be in the It would be the second. The second would be the valence electrons. So you should have a like plus +8 because you would only have two shielding. Um, so yeah. And then for the transition metals, it's supposedly different too. Um, I don't really see that though. They're gonna have high thing, but it's because they have an S, not S, a D orbital. Okay. In what direction does electronegativity trend go? It's up toward y equals x, increasing. Where are the halogens on group 17? What is electronegativity? It is the like it's like it's hard for me to differentiate this from electron affinity now. Like now that we're thinking about it, like now that we established electron affinity, what is electronegativity? It's a measure of the force with which it pulls electrons to itself. So electron affinity is how much it wants it, and electronegativity is how much force it uses. Let's see if that's accurate. I looked that up. Um, okay. So electronegativity mostly applies more for bonds. So like for situations where they have to share electrons, like covalent bonds. Um, so it's not going to be like while electron affinity is speaking on like isolated atoms and they're like how much they would want an electron. It's like in terms of energy. So like while electronegativity isn't, it's on like a relative scale. It says. I don't really know what that means, but I think I'm just gonna run with that. Uh, Measure a force with which an atom pulls electrons to itself. I'm gonna add that on too. I'm gonna add it in a bond. Okay, so as you move from left to right on the periodic table, yeah, I said this one was easy pickings, and look at how long I'm taking. Um, um, as you move from left to right on the periodic table, what way do elements change? Uh, okay, so you get more protons, electrons, and neutrons. Um, and the Zeph also increases. What are the general characteristics of metals? They're gonna be lustrous solids with high melting points, malleable and ductile, and good conductors of heat and electricity. What are metalloids? Where are metalloids? They're between the metals and the non-metals. Where are metals found? The left and the middle. Where are non-metals found? On the right side. Where are what are the general characteristics of non-metals? Okay. Brittle solids with no luster can also be gases, poor conductors. Atoms will gain or lose electrons in such a way so as to achieve a full shell, aka noble gas configuration, I guess. Yes. What special case must we remember when considering ionization energy? Uh, it's probably I'm gonna say that it's probably gonna say that the noble gases are inert. Um, oh, it didn't say that. Um, what are the general characteristics? It is brittle, um, with no luster. They can be gases, and they're poor conductors of heat and electricity. Such a way to achieve a noble gas configuration. Atomic radius is going to decrease from left to right, and it's going to increase downward. So it would be increasing. It would be increasing. Okay, I'm starting to realize a problem in the way that I'm describing it by mathematical functions. There's no arrow on those, obviously. I was just figuring like, okay, like going in the positive direction. I don't really know how to describe this one, but it's fundamentally going like it's gonna go like this. This is gonna be the direction that it's gonna. No, that can't be true. That's not true. I'm lying. It's gonna increase. So if it increases, it's gonna decrease that way. It's gonna increase this way. It's gonna increase this way. So that means it's increasing this way. Yep. What is the effective nuclear charge? Uh, it is fundamentally the number of valence electrons. It's shielding electrons minus the outermost electrons. Or it could be like protons, like weirdly enough, protons minus shielding electrons. Okay, I'm gonna give myself again. I feel like I described that wrong. What special case must we remember when considering? So after they get a full octet, the ionization energy increases massively. Um, what is electron affinity trend? Y equals X. Increasing Y equals X. Where are the alkaline metals? Group one. What is Y equals X? Group two. What is electronegativity? That is a measure of how much, like the amount of, it's a measure of the amount of force used in order to get a to like attain an extra electron, um, in a shared in the case of a, like where those electrons have to be shared, so like in a bond. Where are the noble gases? Group 18. What do rows allow us to easily ascertain? Uh, I mean, like they tend to have, I think, like similar. I don't want to say similar chemical properties. That might be groups. I don't know. Energy level at which, bruh, energy level at which the valence electrons reside. I guess, yeah. What is the effective nuclear charge? Um, it's Zeph is equal to the protons minus the shielding electrons. As you move from left to right on the periodic table, in what way do elements change? More protons, neutrons, electrons, and Zeph. What are general characteristics of metalloids? Bumble. I don't know, bro. No general characteristics. Each is distinct with both metal and non-metal characteristics. Perfect. I love an except. I love, bro. Exception. An exception that'll stand out. I don't need to memorize a list. That's beautiful. Second ionization energy will always be higher. Yes, same thing. As one goes right across the periodic table, effect goes right across. Effective nuclear charge increases. What are general characteristics of metals? Lustrous solids, uh, with high melting point, um, malleable and ductile, and good conductors of heat and electricity. What do rows allow us to easily ascertain? Um, I forgot. Energy level at which the energy level that the band spectrums are in. What is ionization energy? Um, uh, 1 second, guys. Okay. What is ionization energy? That is the amount of energy required to remove an electron. Um, can you only remove an electron from a gaseous atom? Oh, I didn't know that. Okay. Okay, so if greater Zeth equals higher ionization energy, then the trend kind of has to be the same, right? Maybe. I don't know. What are the general characteristics of metalloids? There are no general characteristics. They have their own unique properties, with some that are metals, some that are characteristics of metals, and some that are characteristics of non-metals. Electronegativity is y equals x, I think. Where are the halogens on the periodic table? Group 17. Noble gas configuration. What do rows allow us to discern? The energy level of the valence electrons. What are the general characteristics of nonmetals? They're brittle, with no luster, and they can sometimes be gases, and they what's it called? Uh, they're poor conductors of heat and electricity. I don't know if I'm like, yeah, I feel like I should be speaking higher than the music, but hopefully it's not too loud. I might lower it a little bit. Okay. What are the general characteristics of nonmetals? Um, General characteristics of nonmetals are um, I just said this. I don't know why I'm still looking at this. Where are metals found on the periodic table? The left side and in the middle, and a little bit on the right. Like, this is such a dumb question. What is the ionization energy? It's the amount of energy required to remove an electron from gaseous atoms. Where are metalloids on the periodic table between the metals and the nonmetals? Where are the nonmetals found? On the upper right side. How does one determine whether an atom's ion will be bigger or smaller? Um, the number of, like, its depth, pretty much. I think not even like it's a combination of like the number of protons, the like the number of protons, and the number of electrons. I guess both of those, with both of those, you could probably figure it out. Metal. Wait, what? Wait, what? Did I read the question wrong? How does one determine whether an atom's ion will be bigger or smaller? Bruh. Metal loses electrons to have smaller ionic radius. Non-metals gain electrons to have larger. Bruh. Uh, okay, I guess. What is electron affinity? Um, what is electron affinity? It is the measure of the amount of it's energy. Electron affinity is the amount of energy. I don't know, bro. Energy released when an atom gains an electron. Describes how easily an atom captures. I feel like I'd be like stumbling with my words so much. Energy released when an atom. Why did I say it like that? What do groups allow us to easily ascertain? Number of valence electrons. Okay. How does one determine? How do I have 20? 20, and it was out of 28. Okay, we're not taking 18 minutes on this. How does one determine whether an atom's ion is going to be bigger or smaller? So, uh, metals are going to lose electrons to be smaller, and nonmetals are going to gain electrons to become bigger. What is electron affinity? It is the amount of energy released. by an atom, or I guess ion, I don't know, gained by an atom when it, the amount of energy released by an atom when gaining an electron. What do groups allow us to easily ascertain? The number of valence electrons. What is electronegativity? It is the amount of force um, used to pull an electron toward itself in the case of shared electrons, like in bonds. What are the general characteristics of metalloids? They have no general characteristics. They have characteristics of both, distinct characteristics of both metals and nonmetals. Atomic radius is decreasing from left to right, and obviously increasing from right to left and increasing downwards. So the trend is something like this, in the same direction I drew it. I'm gonna give myself that again, just because I got it right, but I feel like it wasn't that. I had to like process the whole like pathway in my head. What do rows allow us to easily ascertain? Um, I always forget. I keep forgetting this. Energy level. What is the effective nuclear charge? Um, Zeph is equal to the protons minus the shielding electrons. As you move from left to right, they get more electrons, protons, neutrons, and Zeph. What? Zeph? What was the name of that like imaginary number in iCarly? Let's see this. Hold up. iCarly imaginary number. DERF. Damn. I just wanted to make sure. I don't know. What special case must we remember when considering ionization energy? Um, must we remember when considering ionization energy? Uh, hmm. Oh, it increases massively once they have a full octet. Atoms will gain or lose electrons to achieve a noble gas configuration. It will always be larger. What do rows allow us to easily ascertain? The the energy level of the valence electrons. What are the general characteristics of metals? They're lustrous solids with high melting points, ductile and malleable, and good conductors of heat and electricity. Ionization energy is the amount of energy needed to remove an electron. As one goes right across the periodic table, effective nuclear charge increases. In what direction does the electronegativity trend go? Um, y equals x. Where are the halogens? Group 17. What is electron affinity? It is the amount of energy released by an electron upon gaining and gain released by an atom upon receiving an electron. What are the general characteristics of nonmetals? They're brittle with no luster. They can be gases, and they're poor conductors of heat and electricity. Where are they found? On the upper right. Where are metalloids between metals and nonmetals? What do groups allow us to easily ascertain? They allow us to easily ascertain the number of valence electrons. How does one determine whether an atom's ion will be bigger or smaller? How does one determine? If it's a non-metal, then it'll be smaller. If it's a metal, it'll be bigger. What are the general characteristics of metalloids? There are no general characteristics. What is the periodic trend for atomic radius? It decreases from left to right, and it increases like this as you go in that direction. What do rows allow us to easily ascertain? Um, it's something about the valence electrons. Um, the energy level of the valence electrons. Atoms will gain or lose electrons in such a way so as to achieve a noble gas configuration. What is electron affinity? It is the energy released by an atom, the energy released by an atom upon receiving an electron. What is ionization energy? The energy needed to remove an electron. Okay, 28 done. Let's increase this, bro. Let's increase it to like, we're gonna increase this to like 110. We'll put it to 120. We're not actually gonna do 120, but I just kind of want this. I want to see what this chapter is. Like, what is the molecular geometry associated with two bonded pairs and zero lone pairs? If okay, look, right. I think here alone, in these alone, there's probably like there's like six options for lone number of lone pairs and number six domains total. And like there has to be a lot of like a good amount of cards on this. Maybe like at least like 15 to 20. Um, we could definitely at least do those. But we can just go through it. What is the molecular geometry associated with two bonded pairs? Two bonded pairs and zero lone pairs. Linear. Um, I kind of read that earlier when I was looking through this deck. Often only one or more than one Lewis structure can be drawn for a compound. Um, oh, okay, I wouldn't have said more than one, but the answer is more than one. Because like you can draw it, but like that doesn't mean that yours is gonna be the most common one. Like this is not gonna be the most common. Because why would it ever want to share? Why would CL share? Like CL doesn't want to share electrons with carbon. Carbon is like a peasant to chlorine. Chlorine doesn't share. Chlorine is like bougie. Chlorine doesn't do sharing. Chlorine was probably an only child with a bad kindergarten teacher, probably. Um, covalent. Um, covalent bonds are generally formed. I have nothing against only children, by the way. That's perfectly normal. Covalent bonds are generally formed. I'm just saying that chlorine is a bad example. Chlorine is bad representation. Hashtag cancel chlorine. Covalent bonds are generally formed uh, between two nonmetals. Yeah. Uh, okay. What is the molecular geometry associated with two bonded pairs and one unbonded pair? What does that even look like? I'm assuming it just means like a lone pair, right? Um, I feel like that's still linear. I feel like it's bent. Two bonding electron pairs and one lone pair. Okay. Often only one or more than one Lewis more than one. What kind of bonds make up a single bond? Only a what is it called? Uh, we have it's a sigma bond. What kind of bonds make up it's a one sigma and one pi. Okay. I'll press again only because they gave an orientation. Like I didn't know that they were gonna do that. Sigma or pi bonds are the longer of the two types of bonds. Um, are the stronger. I think low key. I think it's sigma. I don't know. Yeah, nice. Thank God. I thought I was about to be right. I was about to be so embarrassing. Um, I don't know what I just said. I think I might have said something crazy. Do all compounds with internal electronegativity differences have dipole moments? Uh, I don't like that word all. I would say no. Yep. Uh, i- if structure is symmetric, the internal dipoles cancel out. That's fair. I understand that. I couldn't even give an example, but I knew that. What is the molecular geometry associated with two bonded pairs? It's bent. Why did I do that? What kind of bonds make up a double bond? Sigma and pi. Bro, I keep forgetting to put the orientation. Molecular bonds are made from overlapping atomic orbitals. What kind of bond do you get when parallel p orbitals on adjacent atoms share electron density? Pi bond. What are London dispersion forces? Those are like temporary dipoles caused by the electron's movement in the atom. Do all no, because they can cancel out. As the polarity of the bonds increases, what kind of intermolecular force increases? Dipole dipole. What kind of bonds? Sigma and pi. I don't even care if it doesn't. Oh my god, bro. Yeah, I'm editing the card. Because if I don't have that in the question, I'm just never gonna answer it. How much the difference in electronegativity beats? How big must the difference must? Okay, so it's gonna be like it needs to be less than I want to say like 0.8, 0.5. Okay, as molecule size goes up. I like, can't read today. This is like insane. It thinks that I'm gonna finish by 3:29 p.m. Yeah, it's not happening, bro. I'm not gonna lie. I'm definitely stopping before 3:29. We're not getting to 3:29 in the morning. Um, maybe 2:30. Maybe like we'll probably stop in like the next 45-ish minutes. If we can't finish in the next 45 minutes, this is not. It's just not happening. Um, as because like realistically, we're trying to do more. That was the goal. The goal was more than what we started with. Um, I think we did 28 in the last one. So our goal is to end up with we if we get to 47. So 40 by 47 here we have done our dues for the day. But we're just gonna do extra. As mole size goes up, what kind of intermolecular force increases? Um, most size goes up. London dispersion. Oh my god, like OD. What are London dispersion? They're like temporary attractive forces caused by a small dipole due to electron density shifting within the atom. What kind of bonds make up a double bond and what kind of each? So you have sigma and a perpendicular pi bond. Covalent bonds are generally formed between two nonmetals. How big of an less than zero point 0.5? What are dipole-dipole interactions? They're interactions caused by dipole moments that exist within both of the like between both of the molecules. What is Vesper theory? Um, I can't. That's like what we use to define like the shape that we were doing before. Predicts the shape of a molecule via arrangement of bonding slash non-bonding electrons. What kind of bonds make up a triple bond? It's one sigma and two pi. One is perpendicular, the other one is parallel. Oh, I feel like that picture is like terrible. Am I bugging? That is a. I don't feel like I'll come back to look at that. I'll come back to look at that if every other picture agrees. Um, triple bond. Um, it's looking like a lot of things are agreeing with it right now. So I think that I think it's genuinely true. It's kind of weird. I feel like that doesn't even look familiar. It's fine. All right. What are dipole-dipole interactions? Those are it's an intermolecular force uh um caused by permanent dipoles that exist within the molecules. Yeah, it's like stronger than London dispersion, obviously because they're permanent. What is the molecular geometry associated with two bonded pairs and one unbonded pair? Bent. It's a theory used to evaluate the shape based on the arrangements of bonded and non-bonded pairs of electrons in the Lewis structure. Are made. What kind of bond do you get from parallel? Those are it's a double bond. Over. Yeah, yeah. What is the molecular geometry associated with two bonded pairs and zero lone pairs? Linear. As the polarity of the bonds increases, what kind of dipole-dipole? Do all compounds with internal? No, it can be symmetrical. What kind of bonds make up a triple bond? Um, two pi bonds and one sigma. I clearly still need to say what kinds. Um, Often more than one. What are dipole-dipole interactions? They're interactions uh, caused by permanent dipoles um, due to unequal sharing in polar compounds, uh, or not compounds, in polar molecules. So it's an attractive force caused by opposite partial charges. It's a pi bond. You get a pi bond, sigma bond. Four bonded pairs and no lone pairs. That's gonna be that's tetrahedral, no? Yeah. What are the exceptions to the octet rule? Uh, like I think when you go below a certain group, I think below like group three, no, what? Not group three. Below the third period, you see expanded octet elements in period 3 plus. Nice. Okay. So, uh, you can have an incomplete octet with helium, helium, hydrogen, helium, lithium, beryllium, boron, everything before carbon. Hydrogen, hydrogen, helium, lithium, beryllium, boron, and then carbon. I don't know if you guys know that song. That song was goaded. Um, what kind of bonds make up a triple bond? It's one sigma, two pi's that are parallel to the sigma bond, and obviously each other. They're both if they're both like, why does it say perpendicular? Those are not perpendicular to the axis. Those are not perpendicular. Hold up. Oh, okay. So what it's saying is that although it's drawn like this, these are the pi bonds, but that's not what's like. That's not what's happening. So it's more something like this. Um, so we have like the C, bro. Why is it? I don't know why it's drawing like that. It wasn't doing that before. Probably for that. If we have that right, obviously we're gonna have like our that's let's just say that's a sigma bond. We're gonna have this. We're gonna have this one, this p orbital, like this, and then we're also gonna have like a, I guess like the best way to draw it would be like this, and then like another one like that, and then like you get the point. It's like copied, and then so that basically these together are gonna form. They're gonna form the those those two interacting. This one with this one, and this one. These with each other. So those two are gonna, and these top two are going to be form this, and these that are going like across like like a flat axis are going to be this one, and then there's like a sigma bond. Okay, I kind of get it. I don't know if that's it. I don't know if that really makes sense. I hope it does, but uh, sigma or pi bonds are the stronger of the two types of bonds. It's gonna be sigma. What are the exceptions to the octet rule? Uh, Basically, has everything before carbon can have less than eight. Everything over the period of three plus can, like groups three plus or periods three plus can have more than eight. Vesper theory is a theory used to predict the shape of molecules based on their amount of non-bonded and bonded electrons. Dun, dun. What are London dispersion? London dispersion is uh damn, I really gotta speed this up. I'm taking a long time. What are London dispersion forces? Uh, um what are London dispersion forces? Those are like temporary forces caused by temporary dipoles. Um due to the electron density shifting like spontaneously. As molecule size goes up, London dispersion forces less than 0.5. These are permanent attractive forces, or these are attractive forces caused by permanent dipoles in the molecules themselves, um, because their polar molecules tend to have internal dipoles or dipole moments that cause an attraction from opposite charges or opposite partial charges, which is dipole dipole interactions. Well, that was really convoluted, but what kind of bonds make up a double bond? A sigma bond and a pi bond. What kind of each? Um, a sigma bond and one a sigma bond and one perpendicular pi bond. What is the molecular geometry associated with four bonded pairs and no lone pairs? Tetrahedral. They're generally formed between two nonmetals. Bent. What are two types of chemical bond? Uh, uh, is this intra and inter molecular? Oh, oh. Um, Ionic and covalent. Okay, cool. Uh, a pi bond. Dipole, dipole. Um, what is bond length? It's like the distance between the nuclei of the atoms in within a bond. That was pretty accurate. I'm not gonna lie to you. Average distance, but I'm gonna give myself hard. Do all compounds with internal electronegativity have dipole moments? No, because they can be symmetrical. What is meant by ideal bond angle? It means that that's the angle at which forming the bond would create the most stability for the molecule. That's exactly what I said. I should give myself easy for that. What are the two types of chemical bond? Covalent and ionic. Nonmetals. Uh, this again. Nonmetals gain or lose electrons. Um, we're gonna we're gonna suspend this card because we literally did it. Suspend. What are characteristics of ionic compounds? I'm not gonna lie. I'm very tempted to just put no new guard right now. Literally just because it said that. I don't want to do this. Um, I don't want to do this. I think I think we're gonna stop that there. I'll be honest with you. We could do our 75. Um, we're gonna finish the rest of these. Then we're gonna do cars, and then we're gonna call it a night. What is Vesper theory? Um, Vesper theory is a theory um, used to determine the shape of a molecule. Um, I just hate memorizing lists. That's why. That's why I don't want to do that. I hate lists. If I have to fit one more list in my head tonight, like it's not even a lot of. There hasn't even been a lot of lists, but I just don't. I don't want to have to overload myself if I don't have to, or I don't want to overload myself if I don't have to. Um, what is Vesper theory? Um, uh, yeah, theory used to predict the shape of a molecule using its non-bonding and bonding electrons, as shown in the Lewis structure. Uh, before carbon can have less than 8 electrons, and elements in periods 3 plus can have more. What kind of bonds? So two bonds that are perpendicular to the sigma bonds, which are pi bonds, and one obviously sigma bond. What is bond length? It is the average distance between two bonding nuclei. The nuclei between two nuclei within a bond. Yes, that's what I said. What are dipole-dipole interactions? It's an intermolecular force that is stronger than London dispersion forces due to permanent dipoles that exist within the molecule itself. It's attractive forces between oppositely charged atoms or opposite partial charges. That was kind of hard, but I don't know. We'll give myself hard. But also tetrahedral. I'm like I just wanted to go through all its shapes. Like I just wanted to like literally I just wanted to remember the shapes. But whatever. I guess tomorrow we might finish this one off and then go into I'll do like 25 of psych or something. Just so that because we ended off on actually it wasn't even a flat 50. I should have ended it off on a flat 50. What are the two types of chemical bond? Covalent and ionic. The angle at which the molecule would be in its most stable configuration. Used to predict the shape of a molecule based on its non-bonding electrons and its bonding electrons as shown in the Lewis structure. Um, an intermolecular force that is stronger than the dispersion forces as a result of permanent dipoles. Um, it is an attractive force caused by opposite partial charges. What is bond length? The average distance between two bonded nuclei. Yay, we did it! What's Oh, we suspended one, but okay. I was about to say, I was like, how did I do 28 and then I did 21 and I added that up. Wait a minute. Wait a minute. Guys, did I think I messed up. I think I messed up my math. I definitely did that math wrong, huh? I don't think I can stop right there. I think I have to continue. I have to do 47 more cards. I don't know why I thought I was done. I'm not done. I'm not done. I can't be done. Um, okay. Okay. So I said I wanted to get off by 2:30. Uh, okay. I think what we're gonna do is we will probably I feel like I'm a lot louder for some reason now. Um, I also feel like the music is a lot lower. Like, okay. So what we are gonna do, we are gonna leave it off there. We're just gonna do cars. I'd rather do the 75. Like I already kind of like I feel like as I continue on with the stream, I feel like you guys probably are realizing that I'm taking a lot longer on the question. Um, but let's see. Let's do let me make sure something. 1 second, guys. Okay. Sorry, guys. Uh-oh. My camera froze. Uh, let's see if I can fix that. Uh, okay. All right. I think we're good now. Um, all right. Let me open up the um the Jack Weston page. So let me change the window that's being captured. All right. Um, if I did this, what would happen? Oh, exposed. Exposed. I'm cooked. Okay, you guys are literally just looking at all the searches I did this stream. I told you guys I was looking at it. Let's see. You guys can look at that. I don't really care. Why is it still saying that that's the page for that? Hold up. One second. There we go. All right. Let's go over here. Let me look for the notepad. That notepad. Notepad. Okay. This was the link. Let me select new. Okay. I'm gonna turn off the lo-fi music. We need to do what's it called? I remember this. I think of this literally all the time. I don't know why I didn't think of it. Encoding specificity. So, all right. Okay. I'm just gonna subtract 3 minutes, or like I'm gonna add on 3 minutes to this. think that's pretty much it. We finished pretty quickly. I mean, I hope I did that fast enough. But yes, okay. 92%. Okay. See. Okay, okay. Let's see why it wasn't is capable of defending itself when it needs to. Why that special argument was about capability. Investigates I don't know. Where is it? Oh man. It was either this one. It was either one. It was either A or D. Bruh. Damn. Okay. 4 for 6. That's better than yesterday. Yesterday we had a 40%. It was we got 2 for 5. So 4 for 6, I'll definitely take it. Definitely a lot better than yesterday's. Yesterday's was kind of crazy. Um, but so today we had a 2 hour long stream, pretty much, pretty close to it. Uh, thank you everyone for watching again, and I'll see you tomorrow.